We shall now deal with some problems on definite integrals. The question 1 goes like this: integral 1 to e cube dx by x into root over 1 plus ln of x. First option 2, second option 2 root 2, third option root 2, fourth option minus 2. The question 1, integral 1 to e cube dx by x into root over 1 plus ln of x. Now, we know that whenever integral of f of x, antiderivative of f of x is capital F of x, then integral of f of x dx by fundamental theorem of integral calculus is equal to f of b minus f of a. So, we will first try to find out the antiderivative of this function and then apply this formula. And clearly, as you can see, the derivative of 1 plus ln x is 1 by x. That 1 by x is seen here. So, what we will do is we will put 1 plus ln of x as t square. Then what do you get? 1 plus ln of x differentiating, we get 2t dt by dx is equal to 1 by x. It implies 1 by x into dx is equal to 2t dt. So, this 1 by x into dx part can be replaced with 2t dt. Now, moreover, when x is 1, from here when x is 1, what is t square? T square is equal to 1. So, that implies t is equal to 1. We will take positive square root there. When x is equal to e cube, what do we get? Ln of e cube will be equal to 3, 1 plus 3, that is 4, t square is 4. So, when x is e cube, we get t is equal to 4, 2. So, the t square was 4 and so t is equal to 2. We will take both to be positive. So, we can rewrite this as integral t ranging from 1 to 2. 1 by x dx is 2t dt, and in the denominator we have root over 1 plus ln of x to be equal to, that is t. So, this t cancels and we have 2t, 2 dt. What are the limits? 1 to 2. So, we will apply, the upper limit will be 4 and the lower limit is 2. So, the answer is 2, 4 minus 2, 2. Therefore, the right option is, answer is in the first option. Let us move on to the question number 2, integral 0 to pi by 2 of 1 by a plus b cos x dx, where a is greater than mod b is equal to, first option 2 upon root over a square minus b square into tan inverse of root over a plus b by a minus b. Second option 2 by root over a square minus b square into cot inverse of a minus b by a plus b under root. Third option 2 by root over a square minus b square tan inverse of root over a minus b by a plus b. Fourth option pi by root over a square minus b square. So, let us look at the question. Integral 0 to pi by 2 dx upon a plus b cos x. Now, this is a standard type of integral wherein you have a rational function of sine cos terms. What the substitution that we go for is tan x by 2 is equal to t. So, put t equal to tan x by 2. Then dx will be 2 dt by 1 plus t square. You can simply memorize this part because that will save some time. You can even differentiate it and see dx is equal to 2 dt by 1 plus t square. Then what about cos x? Cos x will be 1 minus tan square x by 1 plus tan square x by 2. So, that is 1 minus t square by 1 plus t square. So, what do we have when we go for a plus b cos x? A plus b cos x will be So a plus b into 1 minus t square by 1 plus t square. So that makes it a plus a into 1 plus t square plus b into 1 minus t square. So a plus b first, the constant term, and then a into t square minus b into t square. So that makes it plus of a minus b into t square. So that is the a plus b cos x part. So now coming back to this, the integral, what do we have? We'll convert into t. When x is equal to 0, t will be 0, tan 0 0. So t is 0. When x is equal to pi by 2, x by 2 will be pi by 4 and tan of x by 2 will be 1. So t ranges from 0 to 1. We'll have to change. Now what about dx? 2 dt by 1 plus t square. Here we have a 1 plus t square also in the denominator. Okay, so what we have, a plus b cos x is a plus b, this 1 plus t square, and here we have a plus b into a plus b plus a minus b into t square divided by 1 plus t square. Now this 1 plus t square cancels out, and what do we have? Integral 0 to 1 2 dt by, this is a plus b, that I can write as root over a plus b whole square plus root over a minus b whole square into t square. Now it's in the form of 1 by a square plus x square type. And what is the integral? 1 by a tan inverse x by a, and of course we have to apply the limits. What do we have? 2 by, the 2 has been taken out. Now we have 1 by a, what is the role played by a here? Root over a plus b, tan inverse of root over a minus b by a minus b into t by root over a plus b. Further we have to divide it by, because it's multiplied with root over a minus b here, so we'll have to further divide it by root over a minus b. So root over a minus b, t ranging from 0 to 1. So what does this turn out to be? It turns out to be 2 by root over a square minus b square into tan inverse of root over a minus b by a plus b. The lower limit is anyway 0, because when I put t equal to 1, it is tan inverse of root over a minus b by a plus b. So when I put t equal to 0, anyway it's 0, so what remains is this, and that is clearly seen in the option 3. So answer is option 3. Let's move on to the third question. Integral 0 to pi by 2 phi tan x minus 3 cot x by tan x plus cot x dx. First option pi, second option pi by 3, third option pi by 2, fourth option pi by 6. So let's see how it goes here. Integral 0 to pi by 2 phi tan x minus 3 cot x by tan x plus cot x. Let's call this integral I. Let's use the property integral f of x dx from 0 to a is same as integral of f of a minus x dx from 0 to a. That is, replacing x from x by 0 a minus x, the integral will not be altering. So we'll use that property here. Integral is from 0 to pi by 2. So now even if I replace, what is playing the role of a? Pi by 2. So if I replace x with pi by 2 minus x, there should not be any change by this property. So let's write it. I is also equal to integral 0 to pi by 2. Now what if I replace x with pi by 2 minus x? So tan x will become cot x, tan of pi by 2 minus x is cot x, so phi cot x, and cot x will turn to tan x, so 3 tan x by tan x plus cot x. Now what we shall do is, we will call this as 1, we will call this as 2, we will add 1 and 2. We will add this equation 1 with equation 2. So what do we get? 2i on the left hand side, and right hand side we have is integral 0 to pi by 2. The denominator is not changing because of course the tan had to become cot and cot has become tan, but it would look the same. So what do we have here? When you add up this phi tan x minus 3 tan x, that makes it 2 tan x. In fact, phi cot x minus 3 cot x, that is 2 cot x. So I can take out 2 common, and then we have this tan x plus cot x. So clearly this cancels, and we have here 2, and that is 2x 0 to pi by 2, that is 2, that's 2 into pi by 2, and 2i is 2 into pi by 2, so therefore I is equal to, we have I is equal to pi by 2, and that's clearly seen in the option 3. So answer is in option 3. Let's move to the next question, question number 4. Integral 0 to infinity e power minus 2x into sine 5x dx. Integral 0 to infinity e power minus 2x into sine 5x dx. In fact, we can use the formula, integral of 0 to infinity e power minus ax into sine bx dx is equal to b by a square plus b square. We look at the options here. First option is minus 2 by 29, second option is 2 by 29, third option is 5 by 29, and fourth option is 7 by 25. It's clearly seen that instead of a you have 2, so this is a is 2 and b is 5. So let's apply in this formula. B is equal to 5, so 5 by 2 square plus 5 square. That makes it 5 by 29. So the option answer is in the option 3. You could memorize this formula and do it. Otherwise also we can actually derive it. That's not a big deal. What do we need to do? We'll call this as I. Take this as the first function, take the second function. What will happen is you will get on the right hand side some part in terms of I. Club them to the left side and get I. So finally the formula, you can easily derive this formula. So we'll just memorize this formula. And then we have b by a square plus b square, and therefore the answer is 5 by 29 in this context, because b is equal to 5 and a is equal to 2 in this context. The question number 5, integral 0 to pi by 2, 3 raised to the power secant cube x divided by 3 raised to the power secant cube x plus 3 raised to the power cosecant cube x dx. First option 0, second option pi by 2, third option pi by 4, and fourth option is pi. So we have this integral 0 to pi by 2, 3 raised to the power secant cube x divided by 3 raised to the power secant cube x plus 3 raised to the power cosecant cube x dx. Again use a property integral 0 to a f of x dx is same as integral 0 to a f of a minus x dx. So we can write this integral I as, we shall replace x with pi by 2 minus x, then secant will turn to cosecant and cosecant will turn to secant. So we will get then 3 power cosecant cube x divided by 3 power cosecant cube x plus 3 power secant cube x dx. So what did we do? We replaced x with pi by 2 minus x. That is, we use this property. There should not be any change in the integral dx. Now observe that this first equation and the second equation had on the right hand sides in the denominator same expression in the integrand. So we could add up these two integrals and the limits are also the same. So 2I will be equal to integral 0 to pi by 2. We shall add them. What do we get? 3 power secant cube x plus 3 power cosecant cube x. Denominator being same, we could add it. 3 power cosecant cube x plus 3 power secant cube x. And what do we have? This clearly cancelling, and then we have 1. So 1 into pi by 2, that is pi by 2. Right hand side is pi by 2. I has to be, this was 2I, I has to be equal to pi by 4, and that's clearly seen in the option 3. Answer is option 3. Let's move to the question number 6. Integral 0 to infinity dx by x plus root over x square plus 1 raised to the power 5. In fact, again we can use a formula here. Integral 0 to infinity 1 by x plus root over x square plus 1 raised to the power n dx is n by n square minus 1, n by n square minus 1. In fact, integral 0 to pi by 2 of secant square theta d theta by secant theta plus tan theta raised to the power n is also same as n by n square minus 1. So what happens is, if you put x equal to tan theta here, this integral will turn into this form. Theta ranges from 0 to pi by 2, secant square theta d theta by secant theta plus tan theta raised to the power n. So we can directly use this formula. We'll use the formula here. What is n? In the case of n, we have 5, so we use the formula 5 by pi square minus 1. Here n is 5, so the answer is 5 by 24. Answer is option 3. Let's move to the question number 7. Integral 0 to pi by 2 sin 2x into ln of tan x dx is first option 0, second option minus 1 by 2, third option 1 by 3, and fourth option being 1 by 4. So what is the integral? Integral 0 to pi by 2 of sin 2x into ln of tan x. Let's see how this problem can be done. We use a property integral 0 to a f of x dx is same as the integral f of a minus x dx from 0 to a. So what is in the place of a? Pi by 2. So we'll just replace it. What do we have here? So the integral I can be written as 0 to pi by 2 sine of 2 into pi by 2 minus x ln of tan of pi by 2 minus x becomes cot x dx. Now this 2 into pi by 2 minus x is sine of pi minus 2x, and we know that sine of pi minus theta is same as sine theta. So this will be just turning into the form of sine 2x only. But whereas ln of cot x is 1 by tan x, so ln of 1 by tan x will make it minus ln tan x, so that becomes ln of tan x with a minus sign. I take it here 0 to pi by 2. What is this turning into form of? This is again I with a minus sign, so minus I is minus I, therefore I has to be 0, and that is clearly seen in the option 1. Option 1 is the right answer. Yeah, let's move on to the next question, question number 8. Integral minus 1 by 3 to 1 by 3 cos x into ln of 1 minus x by 1 plus x dx. First option 0, second option 1 by 3, third option 2 by 3, and fourth option 2 by 5. Now let us have a close look at the options there. We have the one of the options as 0 now, and the integral is from minus a to a. So that is, it's like minus a to a type. Whenever you have a definite integral from minus a to a, f of x dx, we use that property, that is, it may be 2 times integral from 0 to a f of x dx whenever f of x is an even function. Whenever f of x is an odd function, the integral has to be 0. Now observe that this part is an even function and this is an odd function, and even into odd is always odd function. So therefore the integral will be 0. So what is it? The property is integral of f of x dx from minus a to a, use property, is 0 if and only if f of x is odd, and it is 2 times integral from 0 to a f of x dx if f of x is even. Now let us observe how this function is an odd function. This is clear that it is an even function. What is an even function? F of minus x must be equal to f of x for all x belonging to the domain. What about odd function? F of minus x must be equal to minus f of x. So if you replace x with minus x here, there is no change in the function because cos of minus x is same as cos x. So that is clearly an even function. What happens to this when you replace x with minus x? This becomes 1 plus x and 1 minus x here. So ln of 1 by t is minus ln t. So what do you get? Minus of this thing. So this becomes an odd function very clearly. So even into odd function is an odd function. So integral of an odd function within the limits minus a to a has to be 0. So we use this property. Okay, therefore the answer is in the first option. Let us move to the next question, question number 9. Integral 1 to 3 dx upon root over x minus 1 into 3 minus x. Options are first option pi, second option minus pi, third option pi by 2, fourth option 0. So let us see. It is in some standard format, integral x ranging from a to b dx upon root over x minus a into b minus x. Of course here a less than b. That is equal to pi. So in fact, is it in that standard form? Instead of a we have 1, so we have this a, this is b, so this should be pi. So we can use this formula, use the formula. But how is this formula arrived? Let us look at that also. We put x equal to a cos square theta plus b sin square theta. Then what will be dx? Differentiation. What is the derivative of cos square theta? 2 cos theta into minus sin theta, that is minus sin 2 theta. And here b sin square theta derivative is b sin 2 theta. So what do we get? Dx will be b minus a sin 2 theta d theta. Dx will be that. So this part can be replaced with b minus a sin 2 theta d theta. When is x equal to a? So x has to be a means theta has to be 0. So this corresponds to theta equal to 0. When is x equal to b? That means b sin square theta. Whenever put theta equal to pi by 2, this part will become 0. So we get b. So theta ranges from 0 to pi by 2 there. Dx is b minus a sin 2 theta d theta. And in the denominator, what do we have? X minus a. What about x minus a? X minus a, what we'll do is this a we'll write it as a cos square theta plus b sin square theta. So that will give me b minus a sin square theta. a cos square theta will cancel and we will be left with this. So root over x minus a will make it root over b minus a into sin theta. Similarly, what do we have about b minus x? B minus x under root will become root b minus a into cos theta. Similarly, so we can substitute that and we get b minus a into sin theta cos theta, that is sin 2 theta by 2. So we'll take it, sin 2 theta by 2 was there, so that I cancelled and put it here. So what do we have now? This b minus a and b minus a cancels, and sin 2 theta cancels, so we have 2 d theta and 2 into pi by 2. That's clearly pi. So we have proved that this integral has to be pi. The substitution we had gone for is x equal to a cos square theta plus b sin square theta. So it's a standard integral from a to b of 1 by root over x minus a into b minus a, x is equal to pi. We are using this formula. Therefore, the answer is clearly seen in the option 1. So answer is 1. So let's move to the next question. Question number 10. Integral 0 to 88 pi root over 1 minus cos 2x dx is first option 176 root 2, second option 88 root 2, third option 44 root 2, and fourth option 22 times root 2. Now let's see how this goes. 0 to 88 times pi of root over 1 minus cos 2x dx. Now we know that root over 1 minus cos 2x is mod sin x, root 2 into mod sin x, because 1 minus cos 2x is 2 sin square x, and if I substitute, if I take the square root, I get root 2 into sin mod x. So that makes it, the integral will be now root 2 times of integral 0 to 88 pi mod sin x dx. We know that mod sine function looks like this: 0 to pi, pi to 2 pi, it repeats. Is the graph of y equal to mod sine x. So what is happening? There is a periodicity of this function. The same graph repeats in a period of pi. So you know that definite integral is something like finding the area enclosed by the curve and the x-axis within some specified x equal to a and x equal to b ordinates. So it is like, you know, we have 0 to 88 pi. We can write this as root 2 times of 88 times integral from 0 to pi of mod sin x dx, because this is a periodic function of period pi. Since mod sin x is periodic of period pi, we are using the property. In fact, that property is this. It turns out to be integral 0 to nt of f of x dx is n times the integral from 0 to t of f of x dx. F is periodic if f of x plus t is equal to f of x for all x. That is, f is periodic function of period capital T. Then we have this formula. It's a property and we are using this. What is in place of n? 88. What is in place of t? Pi. This is n and this is t. Because mod sin x, this function is periodic of period pi. So we can write this way. And this is clearly root 2 times of 88 into, we know that mod sin x integral from 0 to pi is nothing but, mod sin x is simply sin x, because sin x is positive in the interval 0 to pi, so it's simply sin x. So integral of sin x is minus cos x. Within the limit 0 to pi, what do you get? That makes it 2. 88 into 2 into root 2. So 176 into root 2. So that's clearly seen in the option 1. So answer is option 1. Let's move to the question number 11. Integral 1 to 2 x square into bracket of x dx, that is bracket x here is the step function of x, and that is greatest integer less than or equal to x. So first option is 7 by 3, second option 8 by 3, third option 4 by 3, fourth option 5 by 3. Now we have to look at where is this function defined actually. Whatever function you are talking about in this definite integral is defined over the interval 1 to 2. And you know that bracket function graph goes like this, 0 to 1 it is bracket function y equal to bracket x. It is constantly 0, 1 to 2, closed 1 to 2 it is constantly 1. So bracket x behaves as function 1. Of course this will change, this is a variable function. Bracket x is a constant function over an interval comprising of the endpoints as integers. So here we have the endpoints as integers, and therefore bracket x behaves as the lower end value. So x square into 1 dx, 1 to 2, and that is x cube by 3, it's clear, 1 to 2. So 1 by 3 into 8 minus 1, that is 7 by 3, and the answer is clearly seen in the option 1. Let's move to the next question. Integral from 0 to a x power 5 dx by root over a square minus x square. First option is a power 5 by 15, second option 8a power 5 by 15, third option 8a by 15, and fourth option 11a square by 15. Integral 0 to a x power 5 by root over a square minus x square. See, whenever you come across this kind of an expression root over a square minus x square, the substitution that we suggested was put x equal to a sin theta or a cos theta. So what we do is we put x equal to a sin theta. And when does x become 0? When theta is 0. So we'll write this x and theta table, x and theta. Whenever x is 0, theta is also 0. Whenever x is a, so a sin theta is equal to a, sin theta must have been 1, so theta must be pi by 2. So the integral will change to 0 to pi by 2. What about x? Sin theta raised to the power 5 d theta. I'm sorry, here dx has to be a cos theta d theta. So we then have a cos theta here, and then in addition we have a cos theta d theta. And in the denominator we have root over a square minus x square, that is again a square minus a square sin square theta, that is a square into cos square theta, under root of that will make it a cos theta. So denominator, this part cancels. So now it is in the standard integral, integral 0 to pi by 2 of sin theta raised to the power 5 d theta. We have a formula. The formula goes like this: integral 0 to pi by 2 of sin theta raised to the power n d theta is n minus 1 by n into n minus 3 by n minus 2. That is, numerator is decremented by 2 and denominator is also decremented by 2. Remember the first term, n minus 1 by n. Just keep decrementing the numerator and denominator by 2. Go on like this. What happens is, it ends up with, if n is an even number, it ends with, n minus 1 will be odd number, so it ends with an odd number 1. So 1 by 2, and the difference has to be 1. Denominator is 1 more than it, and what you get is sin theta raised to the power 0 integral, that will be pi by 2. So it ends with 1 by 2 into pi by 2 if n is even. If n is odd, it is n minus 1 by n into n minus 3 by n minus 2, so on so forth, 2 by 3 into 1 if n is odd. So we make use of this. N is, in this case, clearly your n is odd. So what do we have here? Coming back here, there is x is a sine theta. So we would have a power 5 sine theta power 5. So we have a power 5 multiplying here. So now get back to this. Use the formula. N is odd, so we'll make use of this. So a power 5 is anyway outside. And what do we have? N is equal to 5. So 4 by 5 into, now decrement this, so 2 by 3. So it stops at 2 by 3. And what do we have here? So it comes out to be 8 a power 5 by 15. So this is the answer, and that's clearly seen. Answer is option 2. Let's move on to the question number 13. Integral 0 to 2 pi of cos x raised to the power 4 dx. First option 3 pi by 4, second option minus 3 pi, third option 4 pi by 3, and fourth option is 0. Now let's see how this goes. We actually have a formula. Integral 0 to pi by 2 of cos x raised to the power n, which is same as integral of sin x raised to the power n dx, and we just now gave a formula for it in the previous problem. What is that? It is n minus 1 by n into n minus 3 by n minus 2, so on and so forth. It ends up with 1 by 2 into pi by 2 if n is even, and it ends with 2 by 3 into 1 if n is odd. The rest of the terms are the same. So on, if n is odd. Now, can we convert this integral into from 0 to pi by 2? Let's see how, if it can be converted. What do? We again make use of this property. Integral 0 to 2a of f of x dx is 2 times integral from 0 to a f of x, provided f of 2a minus x is equal to f of x. Now if I replace x with 2 pi minus x, this is, let's treat it as 2a. So what is a? Pi. What if you replace x with 2 pi minus x? That's what you have to do. So f of 2a minus x, cos of 2 pi minus x, we know it's same as cos x. So f of 2a minus x is equal to f of x. So it does satisfy this property. Therefore, what is it? We can write this to be 2 times integral from 0 to pi. So we can rewrite this integral as 2 times integral from 0 to pi of cos x raised to the power 4 dx. Again, I can treat this further as 2 into pi by 2. This is again in the form of 2a. F of 2a minus x is equal to f of x. Cos of pi minus x is minus cos x, of course, but it is raised to an even power. So cos of pi minus x raised to the power 4 is same as cos x raised to the power 4. So there would not be. Again, this property can be invoked, and we'll write it as 2 times integral, 2 times of 2 into 0 to pi by 2 of cos x power 4 dx. Now we can use this formula, first formula, because n here is even. So what do we have? 4 into, n is 4, so 3 by 4 into, decrement it 1 by 2 into pi by 2. So this 4 and this 4 cancels, and what do we have here? 3 pi by 4. 3 pi by 4. So clearly that is seen in the option 1. So answer is option 1. Let's move to the next question, question number 14. Limit n tends to infinity 1 by n plus 1 plus 1 by n plus 2, so on up to 1 by 2n is equal to first option log 2, second option log 3, third option 4, and fourth option pi by 2. What is the question? Limit as n tends to infinity, 1 by n plus 1 plus 1 by n plus 2, so on 1 by 2n. The 2n we can write it as 1 by n plus n. Now we find a pattern here. It is limit n tends to infinity, sigma r ranging from 1 to n. Let's write the general term. This part is common in every term. The second part is varying 1, 2, 3, so on. So when it comes to rth term, what do we get? 1 by n plus r. We can bring it into the standard format. What we do is we take out a n common in the denominator and we write this other part 1 plus r by n. Now this is a function of r by n. It is like f of r by n. This is like sigma r ranging from 1 to n, 1 by n into f of r by n. It is turning into that form. And we know that from one of the formulae that definite integral is a limit of a sum. This turns out to be the integral 0 to 1 of f of x dx. That is this limit 1 by n into f of r by n, sigma r ranging from 1 to n, limit of the sum will be integral f of x dx from 0 to 1. So what do we have in place of f of x? So this is our f of r by n. X has to be replaced with r by n. So what do we get? So finally this comes out to be 1 by 1 plus x dx 0 to 1. And that is ln of 1 plus x. And within the limit 0 to 1, so that makes it ln 2 minus ln 1, so that is 0, ln 2. The right option is clearly seen in the option 1. Answer is 1. Look at the question number 15. Limit n tends to infinity, 1 by 1 plus n cube plus 4 by 8 plus n cube plus 9 by 27 plus n cube, so on and so forth, 1 by 2n is equal to first option 1 by 2 log 2, second option 1 by 3 log 3, third option 1 by 3 log 2, fourth option 1 by 2 log 3. So let's see. Limit n tends to infinity, 1 square by 1 plus n cube. You can write this as 1 cube plus n cube, 2 square by 2 cube plus n cube, and we have 9, we can write it as 3 square by, and in the denominator we have 27 plus n cube, that I can write as 3 cube plus n cube, so on and so forth. The last term would be n square by n cube plus n cube. So that makes it 1 by 2n actually. So that's what was given to us, limit n tends to infinity of this. So we have, now it's clear from here that the general term, rth term will be r square by r cube plus n cube. Limit n tends to r ranging from 1 to n, sigma r ranging from 1 to n, and limit n tends to infinity. So again we have to bring it into the standard format. What is that? We use limit n tends to infinity, sigma r ranging from 1 to n of 1 by n into f of r by n is integral 0 to 1 of f of x dx. So let's see how we can transform it into that form. So we need a 1 by n factor. So what do? We will divide the numerator and denominator by n cube. So what do we have here? We will then write limit n tends to infinity, 1 by n into r square by n square. That's the numerator part. I divided the numerator with n cube. Now what do we have here? R by n cube plus 1. Now this appears to be now a function of r by n. This is f of r by n. So while you are converting the summation into the integral, in place of r by n we have to replace it with x. So r by n has been replaced with x, and then we have this. So what is f of x now? X is square by x cube plus 1. So that turns out to be integral x square by x cube plus 1, 0 to 1. Now let's multiply and divide by 3, so that the numerator turns out to be the derivative of the denominator. So that makes it 1/3 of log of x cube plus 1. We got to apply the limits 0 to 1. Upper limit value is log 2, 1/3 of log 2. Lower limit is anyway 0, log 1. So 1/3 of log 2, and that is clearly seen in the option 3. So answer is option 3. Let's move to the question number 16. Integral 0 to 1 cos of 2 times of cot inverse of root over 1 minus x by 1 plus x dx is first option minus 1 by 2, second option 1 by 2, third option 0, fourth option is 1. Now let's see how this can be done. Integral 0 to 1 of cos of 2 times of cot inverse of root over 1 minus x by 1 plus x dx. What we do is we put x as cos 2 theta. What do we get? Dx will be minus 2 sin 2 theta d theta. So this dx part can be replaced with that. And what about this function? We know that 1 minus x by 1 plus x will be tan square theta. 1 minus cos 2 theta is 2 sin square theta, 1 plus cos 2 theta is 2 cos square theta, and under root of that will give me tan theta, not tan theta, but in this case we can, tan theta is positive, assuming that we can write like that. And therefore cot inverse of this I can write as cot of pi by 2 minus theta. So cot inverse of root over 1 minus x by 1 plus x will turn out to be cot inverse of cot of pi by 2 minus theta, that is pi by 2 minus theta. So this will turn out to be, the integral will be cos of 2 times of pi by 2 minus theta. Integral turns out to be theta ranging from, when is x equal to 0, cos 2 theta has to be 0. So 2 theta I can take it to be pi by 2, so theta is pi by 4. When is cos 2 theta equal to 1, 2 theta is 0, and we have here minus 2 sin 2 theta d theta. We know that this becomes cos of pi minus theta, 2 theta. So that makes it theta ranging from pi by 4 to pi 0, cos of pi minus 2 theta into minus sin 2 theta d theta. I will interchange the limits. So theta from 0 to pi by 4, I will absorb that minus sign here. What is cos of pi by 2 minus pi minus 2 theta? Minus cos 2 theta. And this minus sign has been absorbed into this integral, that is I have interchanged the limits. So that minus sign goes, and we have here 2 sin 2 theta d theta. So if this is f of theta, it's clearly this is f dash of theta. What is integral of f of x into f dash of x? That is f of x whole square by 2. So what do we have here? It becomes minus cos 2 theta whole square by 2 within the limits 0 to pi by 4. What do we get here? 1 by 2 we can take out common, and cos of 2 into pi by 4, that will make it cos pi by 2, that is 0. So that makes it 0 there, and we get again cos of 0, that is minus 1, 1 here. So 0 minus 1 minus half. Therefore the value is minus half there. So our right option is in the first option. Let's move to the question number 17. Integral 0 to 1 x into e power x by x plus 1 whole square dx is equal to the first option e by 2, second option e minus 1 by 2, third option e by 2 minus 1, fourth option e minus 3 upon 2. So let's see how this can be done. Integral 0 to 1 of, I will rewrite this integral as e power x into x by 1 plus x whole square. This x by 1 plus x whole square, we'll add and subtract a 1 here. X by 1 plus x whole square, I am going to write like this. And split it into two partial fractions. So x by 1 plus x plus 1 by, that makes it x 1 by x plus 1 minus 1 by x plus 1 whole square. Now clearly it's, if you take this as f of x, this is like, this part is f dash of x. So f of x plus f dash of x. We know that integral of f of x e power x into f of x plus f dash of x dx, the definite integral, is known to be e power x into f of x. I mean indefinite integral. So what, we'll apply the limits now. So it just turns out to be e power x into, what do we have in place of f of x? 1 by x plus 1. So integral turns out to be e power x by 1 plus x, 0 to 1. Apply the limits. What is the upper limit? E by 2. Lower limit will be a 1, e power 0 by 1. So that makes it e minus 2 by 2, or e by 2 minus 1. That's clearly seen in the option 3. So answer is in the option 3. Let's move to the question number 18. If f of x is equal to f of a minus x and g of x plus g of a minus x is equal to 2, then the integral from 0 to a f of x into g of x is equal to, first option 0, second option a, third option 0 to integral 0 to a f of x dx, and fourth option is a square. So what are we given? F of x is equal to f of a minus x, and we are also given g of x plus g of a minus x is equal to 2 for all x, and we are asked to find out the integral 0 to a of f of x into g of x. We use this property. I replace x with a minus x. Replace x with a minus x, there should not be any change in the integral. So 0 to a f of a minus x into g of a minus x. But what are we given about f of x? F of x and f of a minus x are one and the same. So I will replace this part with f of x. Integral 0 to a f of x into g of a minus x dx. Now this is I. Now what we do is we call this as equation 1 and now equation 2, and now let's add up these two equations. Adding 1 and 2, what do we have? 2i is equal to integral 0 to a, the limits are the same. So we could club them, f of x into g of x and f of x into g of a minus x. F of x is common. What do we get? G of x plus g of a minus x. And this part is already known to be 2. So we can replace that with 2. So it comes out to be 2 times of integral 0 to a of f of x dx. And this 2 and this 2 can be cancelled. Therefore, I is equal to integral 0 to a f of x dx. That's clearly seen in the option 3. So answer is option 3. Let's move to the question number 19. Integral 0 to 1 of log of 1 plus x by 1 plus x squared dx. First option pi log 2, second option pi by 8 log 2, third option pi by 4, and fourth option minus pi log 2. Put x equal to tan theta. So whenever you come across an expression 1 plus x square in the integrand, the general substitution that is suggested is putting x equal to tan theta. So what if I put x is tan theta? Theta will be ranging from 0 to pi by 4. Because x is ranging from 0 to 1, so we'll have the integral from theta ranging from 0 to pi by 4. And we get ln of 1 plus tan theta here. Dx is secant square theta d theta. So secant square theta d theta. And 1 plus x square is again secant square theta. So this cancels and we are left with ln of 1 plus tan theta d theta. theta ranging from 0 to pi by 4. Now the same I can also be written as 0 to pi by 4. Again replace theta with pi by 4 minus theta. So ln of 1 plus tan of pi by 4 minus theta. We'll add up these two integrals. So what do we get? 2i will be equal to integral 0 to pi by 4 ln of 1 plus tan theta ln x plus ln y is equal to log of x into y. So that makes it 1 plus tan theta into 1 plus tan of pi by 4 minus theta. So what do we use? We just use the property of logarithm. Log x plus log y is log of x into y. So I just made use of that. So we have here this bracket. Yeah, this one more bracket. And now we also know that 1 plus tan theta into 1 plus tan of pi by 4 minus theta is 2. This is a property. You can just use that formula of tan of A minus B and then get it. You will be left with 2. So this comes out to be 2i is coming out to be integral 2 times of 0 to pi by 4 of simply ln this becomes ln 2. So ln 2 d theta. So ln 2 into pi by 4. That was 2i. So I will be pi by 8 ln 2. So that is clearly seen in the option 2. Answer is in the option 2. The standard integral, that is ln of 1 plus tan theta 0 to pi by 4. You can actually memorize this. This is pi by 8 log 2. Worth memorizing. This part memorize. Let's move on to the next question, question number 20th. Integral 0 to pi of x into f of sin x dx is equal to k times integral from 0 to pi by 2 of f of sin x dx. Then the k value is first option pi by 2, second option pi, third option pi by 3, and fourth option is 0. We have the integral from 0 to pi of x into f of sin x dx to be equal to k times of integral from 0 to pi by 2 of f of sin x dx. We'll see how it can be done. Let's move on from the left hand side. So what is the left hand side? I is this. I call this part as I. I replace x with pi minus x. And we have here, so therefore pi minus x into f of sin of pi minus x. Sin of pi minus x is sin x only, so this doesn't change. Now let's add these two. We get 2i is equal to f of sin of pi minus x is f of sin x. So this will be taken common. F of sin x is common. X plus pi minus x, that makes it pi into f of sin x dx from 0 to pi. Now this further we can write it in the form of pi can be taken out, 0 to 2 times integral from 0 to pi by 2 of f of sin x. What is the property that we made use of? We made use of this property. Integral 0 to 2a f of x dx is 2 times integral from 0 to a of f of x dx, provided f of 2a minus x is equal to f of x. Now the role played by this is 2 into pi by 2. We'll call this as 2a. This is like 2a. F of 2a, that is what? F of 2a minus x. Sine of f of sine of 2a minus x. That is pi minus x. That is f of sin x only. So there is no change in this. So it is obeying this condition. So we can write it. So now this is 2i. 2i is equal to 2 pi into integral 0 to pi by 2 of f of sin x, 2 pi. This 2 and this 2 can be cancelled, I is equal to this. So the left hand side is now turning out to be pi into integral 0 to pi by 2 of f of sin x. Therefore, clearly comparing this and this, here we have k to be pi. So answer is clearly seen in the option 2. Answer is option 2.